Yes. Okay, we're on balancing oxidation-reduction reactions. We are skipping the warm-up. And I'm going here to the conservation of mass and charge. So in oxidation-reduction reactions, the charge is balanced by making certain that the number of electrons lost equals the number of electrons gained. A lot of redox reactions are more complicated, but today we're going to be looking at balancing the half reactions, so balancing the oxidation and reduction half reactions and then bringing them together to write an overall redox reaction. So what I'm going to have you look at is separating reactions into half reactions and then balancing them in solution. So let's take a look at the next page. And half reactions are going to include the number of electrons that are lost or gained. And we usually specify whether the reaction is taking place in acidic or basic solution. Most of the time it will be acidic. When it is not, they will tell you because we do two different things if it's acidic versus basic, and I'll go over that in a second. So we're going to take a look at the instructions here on balancing half reactions. They are outlined very, very well for you. The first step in balancing is to balance the atoms other than hydrogen and oxygen, and we will do that with coefficients. Step number 2 will be balancing the oxygen atoms by adding water. Step number 3 will be balancing hydrogen atoms by adding hydrogen ions. And then step number 4 will be balancing the charge by adding electrons. Okay? We always add electrons to the more positive side. It says that down here. Always add electrons to the more positive side. You should star that. Okay? And the reason we add electrons to the positive side is we bring that side down to meet whatever the charge is on the other side. Okay? And we'll do that in a sample problem. If you turn to the next page here, they add one little step if it's a basic solution. So the steps that I just outlined, steps 1 through 4, that's what you follow only for acidic solutions. If it's basic, we add one more. Okay, so all you have are 4 steps if it's an acidic solution, but if it's a basic solution, you will add step number 5. Star this one. This is for basic conditions only. Okay? When you have basic conditions, you have to add hydroxide ions to both sides to neutralize all the hydrogen ions that had been added. Okay? And then we'll combine them to make water. Instead of outlining these details in the reading, I'm just going to show you in a sample problem because it makes a lot more sense. Okay? So let's take a look at sample problem number 1. So we're going to balance the following half reactions, and we're going to assume that the reactions occur in an acid unless stated otherwise, and then we're going to indicate whether the half reaction that we're looking at is an oxidation or a reduction half reaction. So for this first half reaction, if we're following the steps, step number 1 says balance atoms other than hydrogen and oxygen. Well, don't I have an SM on each side? So those are already balanced. Step number 2 says balance oxygens by adding water. Do we have any oxygen? No. Step number 3, balance hydrogen. Do we have any hydrogen? No. Step 4, balance the charge by adding electrons. Which side do I add the electrons to? The more positive side, which would be the right side. Because I have a +3 here and this is neutral, right? This is just 0. So you would add 3 electrons and we're balanced. We're done. Because I brought this side down to 0 to match the other side. Does that make sense? Okay, is this oxidation or reduction? Leo the lion goes GER. Leo, loss of electrons. oxidation. So this is a loss of electrons. So this would be oxidation. Does that make sense? Mm-hmm. So when the electrons are coming off on the product side, that's an oxidation. When the electrons are on the reactant side, that's reduction, because you're gaining them. Good enough? Mm-hmm. I can proceed. Mm-hmm. Okay, let's look at number 2. I'm going to write number 2 over here, and I'm going to give myself some room. Okay. Step number 1. Balance atoms other than hydrogen and oxygen. Are my nitrogen balanced? Yes, so I can go to step 2. Balance oxygen atoms by adding water. I have 3 oxygen atoms here, so you would have to add 3 water molecules to the right side to balance your oxygen. Can I go to step 3? Mm-hmm. Balance hydrogen atoms by adding hydrogen ions. How many hydrogens do I have here? 4. How many here? 6. 6 plus 4 is 10. Okay, so I'm going to have to add 10 hydrogen ions here. Step 4. Balance the charge by adding electrons. The total charge on this side is a plus 10 here and a minus 1, which is plus 9. So this is plus 9. This is plus 1. So which side would I add electrons to? The left side. So we would add how many electrons to bring it down to meet this plus 1? 8. Did I lose anybody? We're good? Okay. Do you want me to do one in basic solution before I give you one to do?
Yes.
Okay, number 3 is basic. So that means we're going to add step 5 on at the very end. So everything will be the same except we'll add hydroxides in step 5. Okay, so IO4 -1 goes to IO3 -1. Step number 1, balance atoms other than hydrogen and oxygen. Well, I have 1 of each iodine, so I'm fine. Step 2, balance oxygen by adding water. I have 4 oxygen here and 3 here, so I should add 1 water here. Step 3, balance hydrogen by adding hydrogen ions. I have 2 hydrogens here, so we're going to add 2 hydrogen ions to the other side. Step 4, balance the charge by adding electrons. Overall, my charge on the left side is a plus 2 and a minus 1, which would give me a plus 1. Agreed? This is a minus 1. So how many electrons should I add? 2. So we're going to add 2 electrons here. I just realized I forgot to label question 2 as being oxidation or reduction. Reduction, because when you gain electrons, you're reduced. So this is reduction, and that's because your electrons are on the reactant side. You're gaining them. Okay? All right, which means this would also be reduction. Okay, now we're not done yet. We're in basic solution, so you have to look at step number 5. Add hydroxide ions to both sides to neutralize the hydrogen ions. Great, okay. So I have 2 hydrogen ions that I had added. So that means I'm going to add the same number of hydroxides. So let's add 2 hydroxide ions to each side. Now, once you do that, combine hydrogen and hydroxide to make water. So over here, I can combine these. So I would end up with 2 waters. Does that make sense? So it's 2 electrons plus 2 water, and then your IO4 going to IO3, and then everything else is the same. Do I have you up until this point? Mm-hmm. Can I simplify anything else? See how I have multiple waters on either side? you have 2 water here, and you have 1 water here. Subtract this one from this side. So wherever you have more water, like you're going to subtract the fewer from it. So this is now going to leave. And now I have 1 left. And you're left with your balanced half reaction, which is this, and you're done. You think you can do this without me? We'll do one. We'll do one. Take a look at number 4. This is an acidic solution, so you're only doing steps 1 through 4 on number 4. Do you guys need my help to start, or are we okay? Add coefficients. Okay. See how you have 2 sulfurs on the left and 1 on the right? So then put a 2 here to balance the sulfur, and then follow everything else as I did before.
Oh, everything except oxygen.
Yeah. Yeah. Do you want me to help you? Since this was a little bit different.
Yeah.
Step 1 was balance atoms other than hydrogen and oxygen. And you have 2 sulfur here. So just put a 2 here to balance the sulfur. Step 2, balance oxygen by adding water. Okay, you have 8 oxygen here. And you have 3 oxygen here. So what should I add to this side? 5H2O. Did I lose anybody?
No.
Does that make sense?
Yeah.
Oh, yeah, because that's when we started.
Yeah. Okay. How many hydrogens do I have?
10.
We're good so far? Okay, now we need to look at the charge. Overall, I have a -2 on this side. On this side, don't I have a -4 because there's 2 of them? So a -4 and a +10 would be +6, right?
Yeah.
So I need to bring this +6 down to meet this -2. So how many electrons should I add?
8.
Oxidation or reduction?
Oxidation.
Does this make more sense?
Yeah.
Yeah. So I had a -2 here on this side, and then I had a -4 here because there's 2 of them, and a +10. So that's a +6, which has to come down to -2. Okay. Do you want to try 5 on your own?
Sure.
Okay.
I add water to the right side?
We should do it to VR.
Oh,
Okay, before you get too far ahead of me,
interesting.
we have 2 bromine here, right? So then you'd have to put a 2 here,
Good.
because that would change everything if you hadn't done
Oh yeah, definitely.
Definitely.
it. Okay.
That's okay. I can just change everything.
So after that, what would you do?
Add water.
Add water. How many water?
6.
6, because you have 6 oxygen here. Okay. Have everybody so far?
Yeah.
Now what?
Add hydrogen.
Yeah, you have 12 hydrogen here, so you would add 12 hydrogen here. Now what? Charges, so add electrons. How many? Yes, because you have a positive 12 here, and then you have a negative 2 here. So that means you really have a positive 10 overall, and that's 0. So you would add 10 electrons. We good so far? Now what?
Combine.
It's basic.
Add your OH.
So add OH, and you have to add the same number of hydroxides as hydrogens that you had added, right?
12 on both sides.
So yeah, so you're gonna end up adding 12 hydroxides to both sides.
Then combine them.
Then combine them. Yes.
Why wouldn't you add? Oh, we're just getting rid of
Okay. So now you're gonna combine the hydroxides and the hydrogen ions to make water. So this is 12 water.
And then cancel.
And then, yeah, you're gonna cancel whatever you have. So since you have 12 water here and 6 water here, you would subtract the 6 from here. So this is gone, and now this is 6. Do you want me to rewrite it, or we understand? Okay. Can you do this, like on a quiz, on paper,
Yeah.
next time?
I wouldn't want to, but I could probably pull it off.
You could probably pull it off. Okay, so we good? Yeah?
Is this?
I'm just gonna fix the code.
And this is
I don't know why I did that.
reduction,
I didn't
yes.
know, and so I didn't think it But it did.
okay.
So it doesn't matter.
Okay, so let's go on.
Oh, there's more? Here's
Okay, that was half reactions, right? So that was just doing the half reactions separately. Now I'm going to bring them together. Okay. There are 2 different methods for completely balancing redox reactions. The first one is called the half reaction method, and that's what I'm going to be doing. The half reaction method is where I give you a equation. It is a redox reaction. You separate them into their half reactions. Then you balance each half reaction, just like we did. You multiply each half reaction by a whole number to balance the electrons, because you have to have the same number of electrons being given up and accepted. And then you add the half reactions together. And then if the equation is basic, you add the hydroxide ions to both sides to neutralize the hydrogen ions after recombining the equations. Okay, I am going to take a look at the practice problems given on the next page, and they are in acidic solution. So we are going right here. And this is all we are doing today. Okay, this is it. Okay, here we are. This is a redox reaction. What do we need to do first? Separate into half reactions. So I'm going to have H3, make sure you leave yourself enough room. H3 ASO4 is going to ASH3, and then we have Zn going to Zn plus 2. Does that make sense? Okay. All right, now, step number 1. Balance everything other than oxygen and hydrogen. I have 1 AS on each side, so we're good, right? I have 1 zinc on each side, so we're good. Step number 2, add water to balance oxygen. I have 4 oxygen, 4 H2O. Do I have any oxygen here? No. Okay, now I need to balance my hydrogen.
Add 8 hydrogen.
You have 8 hydrogen here, but how many here?
Oh, 5.
3. So yeah, add 5 hydrogen to this side because I have 8 hydrogen here, and I had 3 here. So 3 plus 5 is 8.
What about the hydrogen on the
Oh, I missed that one. Good call. Good catch. Good job. Good job. So 8 plus 3 is 11. So good job. We good?
Mhm.
Okay, now what?
It's 8 specific. Okay. So do the electron.
Add the electrons. How many?
8 on the left side.
Right.
Yes. Because it's plus 8.
This is neutral. This is 0. This is a plus 8, so you'd have to add 8 electrons to bring that down to 0.
Yes.
What do I do here?
Add 2 electrons.
Add 2 electrons. Okay. Now, do I have the same number of electrons? No. So what does that mean? You would multiply by 4. You would take this entire thing and you would multiply by 4. Because you have 8 electrons here, you need to have 8 electrons here. So this becomes 4 Zn going to 4 zinc ions and then 8 electrons. Now you're going to bring this together. You're going to have 8 electrons, 8 hydrogens, H3, ASO4, and then you're going to put your 4 zinc here. I have ASH3, 4 water. I have 4 zinc ions and 8 electrons. So all of the reactants went together and all of the products went together.
Can we cancel out the electrons or is that not it?
Yep, you get to cancel electrons because we have 8 electrons on each side. And I think that's it. What do you think? Not bad.
If you were to have it on a test, would we have to cancel the electrons?
Yeah. Yeah. So your quiz next time will be on paper. It will be one of these.
Just one.
Just one.
Oh, that's bad.
No.
And it won't be basic.
No.
Okay.
That's fine.
If it was.
Okay. Do you want to try the next one on your own?
Sure.
Oh, let's
So we don't have to add coefficients because there's 2 C's. Even if there's one, I can just spread out. Okay. Here's where I'm having to add new electrons to that point. Do you add two each? Oh wait. I added one for that side because there was 6 oxygen. So I was trying to get one on that side. Didn't see that. A bit hard. And then I had 2 hydrogen on the other side. And then I had 2 plus, 2 minus, and then 0 on that side, so I didn't add any electrons. That's correct, because what did you say? 1 electron to this side? Before. Oh, I think yeah, behind. Two inches. Would you combine?
If they're on the same side.
Okay. So then I don't know if we multiply it now because there's no electrons.
What if there's no electrons?
There's no electrons.
Like,
I'll do the NO3 to the N2O4. They're like,
You should have electrons.
if we put a coefficient of 2
Oh,
in
'cause
front
it's
of
If you
it.
have a coefficient of 2 here,
2 minus 1. So then
You
I
started
do 1. So then you put 1 electron over here.
you started with a coefficient of 2 here,
Yeah.
and then you had 6 oxygen.
That would make sense. Oh wait, but 2 and then 2.
Did you do this?
I added 2 water to that side.
And then how many hydrogens did you add?
2.
4.
Oh.
I see. So silly.
So then you're gonna have to have electrons.
Yeah. So we should have 2 electrons on that side.
Yeah.
Which I don't know what.
So there's that one.
Okay, and then we'll do the little multiply thingy
Right.
where we do that. And then we're gonna add them all up together. So
Uh-huh.
If the electrons are on the same side, would you just add them together? Like when you're putting the two equations together?
They should be on different sides.
Oh wait, yeah.
Did you get this for that half reaction?
perfect.
Oh yeah, I see what I did.
Okay, so now we have H2O plus C2H5OH plus 8H plus 4NO3 minus.
Do you want me to
Don't
wait
need
for
the
you?
electrons. Then we
Or do you want me to proceed?
CH3COOH
You added more
Combine them.
H2O. And then can we cancel out hydrogens and waters? I feel like we can.
Do you want me to explain this half reaction and then, or are you ready? Or do you want me to wait?
I have it all out and I canceled out the electrons, but can we cancel out waters and hydrogen ions?
Cancel out hydrogen ions, yes, and combine water.
We can't cancel out waters, but we can
You can cancel out a water.
Oh yes, I can.
Yeah.
I see.
Okay.
Yeah.
That would be a happy.
Because you had a +4 and a -2.
Yeah.
You cancel there. So excited.
Yeah.
So you cancel out what stuff?
That's the whole point, to get them to be able to cancel out. So you have that.
Does it matter the order that you said?
No.
Okay. Okay.
Oh, it matters the order?
No.
Oh, good.
Or
Okay.
just have them
I
go
like
in
no.
This is our final answer.
Yeah.
Oh, I still have to cancel out stuff.
Okay, can I go? Are you ready?
I'm ready.
So, what did you do first here? Did you add water?
Yeah.
One?
Yes.
And then you saw that you had 5, 6, 7, 8 hydrogens here.
Yeah.
And you had 4 here.
Yeah.
So you added 4 hydrogens here.
Yes. Yeah.
Then you looked at the charge.
Yeah.
You added how many?
4 electrons.
Okay. Do the electrons match?
No.
No. So what did you do then?
Multiply by 2.
So you multiply this entire reaction by 2, which gave you.
So would it be 2?
No, so like when you multiply this whole thing by 2, like you should put like 2 in front of here and then like 4 here. That makes sense.
Okay.
And like
Oh,
8
okay.
here. Well, like
You got
it
that.
depends, like depending on how you like connected it together.
Then
Yeah.
you were allowed to bring these two together, right?
Yeah.
Which made for something that was kind of long. Oh my gosh, it keeps going. Okay.
Oh my gosh.
Okay.
I actually got it right.
Okay. Now,
I'm so happy.
Cancel electrons.
cancel electrons.
I really forgot about
Cancel hydrogen ions on the right side, which leaves 4 on the left.
You had 4 hydrogens here, 8 hydrogens here. So this is gone. This became a 4.
Then cancel out waters on the left and
You had-
F.
Yeah, 1 water there, 4 here. So this is gone. This became a 3.
Yeah.
We good?
Yeah.
Yeah.
Oh my gosh,
I might go back.
Stuff is really multiply.
Yeah, no, that's just it. That one, like,
Let's do tomorrow.
Dude, literally? Here's
That's
Yeah, that's it.
yay.
Are we not ever learning the other stuff?
The rest of the stuff in the section? We're not going to do disproportionation reactions.
Like ever?
Do you want to?
Can I cross it out?
You can cross it out. We're not going to do that because you can't break those. It's hard to break them into half reactions. Therefore, we are not doing them.
This is like the half.
Okay? So we're done with this section.
Of course.